give you this, the definition of a limit. This is what you'll find in your textbook. If I say the limit as x approaches a number I will call c for a function is the value L, what this means is when I take a value c, when x is close, close to the value c, when I take a number that's close to the value c, but not equal to c, f of x will be close to the value L. What this is saying is that if I am taking a limit as I am approaching the number c, in the previous example, that is a limit as I'm approaching the value 3. Yes? If I take a number that's close to 3 and I plug it into the function, the answer I will get will be close to the limit of the problem. But I am not allowed, technically speaking, to plug in that value itself. Questions there? Again, though, that's just the definition in your textbook. What you really need to be able to do is follow those steps that we just did a while ago. Now, the work that we just did right here can also be expressed using graphs, limits, and graphs. If I was to draw some lovely axes, and then I have my function, the graph of my function I had a while ago was 10x plus 3, I think. Okay, wait, but either way. So the graph of my function, 10x plus 5. Yeah, 10x. The graph of my function will look something like this. So if I have this function right here, and then this value right here is 35 right here, and this value right here is 3. What happened was I started over at 2, right? And then I kept plugging values that got closer and closer to 3, correct? Well, what happened was every time I plugged in a value into the equation 2.5, the corresponding answer I got resulted in an answer that's closer to 35, right? When I plugged in 2, I believe the answer was 25. When I plugged in 2.5, what was the answer I got when I plugged in 2.5? The answer was 30. When I plugged in 2.9, the answer was 34. So every time I plugged a number that was closer to 3, the answer I got closer to 35. Similarly, when I take numbers on the other side, say for example 4, 3.5, 3.1, if I take each of those numbers and then I plug it into the function, the corresponding y values that I got each time gave me an answer that was closer to 3.5. So I got answers like I think 45, and then 40, and then 30, 36. Yeah, 30, 35.1. And so what happens is, again, each of those numbers are getting closer to 35. So this right here, this graphical representation is me representing the table of values, but me just doing it for graph instead of using table. Questions there?
No.
Comment.
Does it matter, like, if hypothetically, like on an exam, you ask us to graph it, can we just put like for the x's 2, 3, 4, and then the y is just 25, 35, and 45, just the whole numbers, the easier numbers, or do we have to put like the decimals too?
Oh, I'm a nice guy. I don't ask you guys to graph much, so you won't end up having to graph it. As you will see, actually,
Okay, thank you.
I'll actually the graph and then ask you to use the graph to get the limit. So, like I was just saying, sometimes I do something like this. And so what I do right here is I give you the function. And my function is something like this, for example. And so let's say right here, this point is 5. That's this corresponding point, and that corresponding point is right here is 7. Right? So I have a function f of x. So obviously below 7 is going to be 6, and above 7 is going to be 8. If I say the limit LIM as x approaches 5 for this function, my question to you, is the answer going to be 8? Is the answer going to be 7? Or is the answer going to be 6? Which of these is the correct answer? Let's see what I have right here. Don't you all answer at once? Oh, I guess the women, y'all still graphing the graph. Kids always take a lovely time graphing graphs. That's the best part of the math class. You gotta draw a pretty picture. So what's the answer to the limit? Is it 8, 7, or 6? There's only one of them. Which one is it?
Say that again.
I want to know the answer to this problem. I'm asking you this, find this limit. And I want you to use the graph to find this limit. I'm telling you x is approaching 5. And I give you 3 possibilities for the answer. 6, 7, or 8. I'm saying which one of these is the correct answer. Which one of these is the limit? 7?
Is there an
The
easier
7?
way to do this other than like graphing it on the XY graph? Because that's what I'm trying to do, but I don't know if there's an easier way to do it. So
The limit is
7.
oh.
I'm going to 7.
7.
Somebody else says 7. Let me show you how we get the answer and then ask the question again. So what I am trying to do is I'm trying to find the limit, correct? So what that means technically is I have a number line, and a number line I start at 5, and then I plug in numbers that get closer and closer to 5, correct? Yes?
Yeah.
Yeah.
So, and then I go to the other side, I plug in numbers, and then, so if I was to do this using this graph right here, so if I plug in a number right here, that'll give me a number, that'll give me an answer right here, correct? I plug in a number right here, and then I go across, I give you an answer right here. If I plug in a number right here, again, I'm not actually plugging the number, I'm just using the graph. I get an answer right here. Can you see that my answers are getting closer and closer to 7?
Yes.
I go to the other side, to the right side, plug a number right here, and I go across. I plug in a number right here, and I go across. If I plug in a number right here on the right of 5, and then I go across again, I get my third answer right here. Can you see that all of these answers are approaching 7? Therefore, the limit is
7.
7.
So because I have the graph, I can visually look at it and then figure out what the limit is without having to actually create a physical table of values. Yes?
Yes.
Yes.
Does that answer your question, Tatiana?
Not really, because I just it does it does it does.
Actually create a table of values because you're just looking at the graph itself.
So, oh, I don't know what just happened. So on the like originally you started with just the 7 on the y-axis and just the 5. So it literally was I don't know. I'll get it if you just. It's fine. I'll catch up.
Let me
Yeah.
do another one then. Let me do another one then. So, tell me if you've ever seen a graph that looks like this before. Have you seen a graph that looks like this before? I guess I should change the color. So. Let me change the color. Oh, my graph. Did not change the colors. Change colors, change. There we go. So this is my x-axis. That's my y-axis right here. And that's the graph. This point right here is 3. This point over here is 9. I have 10. I have 8. And so my question to you is, what's the limit for my function? Oh, that's not the right. What's the limit for my function as x approaches 3 based on the graph? The answer, 8, 9, or 10. Questions? Anybody? Anybody? For some reference,
9.
8 is right here. 9 is right here. And 10 is right here. Anybody wants to try and tell me what the answer is? 8, 9, or 10? It's one of them.
9.
9.
You sure?
8.
You sure? I can make a guess.
No, it's 9.
9.
So if I take a number close to 3, give me a number that's close to 3, let's say right here, and I plug it into the function, I get an answer that's right here, correct? If I take a number that's closer to 3, and I plug it in right here, I get an answer here. If I take an answer right here, even closer to 3, I get an answer right here, correct? Every single time, what number am I getting closer to? Here, to here, to here. What number am I getting closer to?
9.
If I go to the other side, if I take a number over here, and I come across, end up right here. If I take a number right here, I go across, I come up right here. Kind of hard to see. If I take a number right here, let me go slower, and then I come across. Again, can you see that every time I'm getting an answer, the answer is getting closer to, and so the limit is 9. Questions there? Comments? Queries?
Why
Go ahead.
on the right side of 3?
Mhm.
I already know it's 9, but like, even though it went low.
Well, yeah, because remember, we're getting closer to 3, correct? So let me switch colors. Let me go with black right here. This is far away from 3 right here, correct? That ended up being down here. Then the next one right here ended up actually being higher right here. And then the next one actually ends up being higher right here. So if you look at the black ones, 1, 2, 3, you can see they're actually moving upwards and heading towards 9. Did I answer your question?
Yes.
Well, let me give you a trick question then. Y'all ready for a trick question?
Sure.
Ooh, one person said sure. All right, all right.
Yes.
So let's say I have a function that looks like this. And the function goes like this. It has an open circle. And you remember what open and a closed circle means, right? Closed circle. And then it goes like this. The open circle refers to the value 15. The closed circle, the open circle refers 15. The closed circle refers to the value 16. And both of these are at x is equals to 2. Based upon the graph of this function, f of x, I ask you to find the limit as x approaches 2 of the function. Is the answer 15 or is the answer 16?
Is it 15?
I have one person saying 15.
15.
2 people.
But like,
15.
can't you just look at the graph and see where they both intercept and just say, okay, this is where this is 2, and it's obviously like, right, I don't know. I feel like I just looked at that. Okay, I'm gonna just let you explain it.
No, I understand what you're saying. And the answer to your question is 90% of the time you're right. The question is this the 10% of the time you're wrong? Because your statement is generally right. Anybody else anybody wants to go for 16? Anyone wants to take a gander on 16, or everybody think it's 15?
Well, doesn't the closed circle mean like, the open circle mean doesn't like never mind.
The open
Can
circle,
you tell us?
the answer is not here. The answer is 16. So the open circles means this. If I take the function and I plug 2 into the function, the answer is going to be 16, because you always go to the closed circle. So if I plug in 2 into the function, the answer I will get is 16. That's what the closed circle means.
What's the point of the 15 being there?
Huh? Well, the point of what's the point of the what?
The 15 there.
Because that's what the open circle is. I'm giving you a choice. It could be 15, it could be 16. I gotta make it a little bit interesting.
Can you?
All saying yourself, can you just show what the answer is already? So I gotta take numbers that are close to 2. So if I take a number right here, I plug it in. I come across here. I'm getting close to this one. I take another number, plug it in. I'm getting closer to 15. I take a number, I plug it in. I go across, I'm getting close to 15. Yes? I go on the other side, take a number, plug it in. I go across, I get in the middle, plug it in. I get closer to 15, plug it in. I get closer to 15. And so both of them are squeezing towards. And so the limit is 15. Questions there? So in calculus, when I'm taking a limit, it is possible for the open circle to be the correct answer. But when you did college algebra back in the day, if I just ask you no limit, just ask you f of 2, the answer would have been 16. Okay? Because the limit is about where I'm approaching. It has nothing to do with the closed circle. It's simply where is the graph approaching as I get close to 2. Questions there?
What does the open and closed circle mean? Can you just go over that for a second?
The open and closed circle means this is the answer when I plug a function in. So let's say I have a graph that looks like this. Open circle, closed circle, closed circle, open circle. Let's say I have a graph that looks like this. Beautiful graph, right? Beautiful, beautiful. If I have this right here as 3, this right here is 7, this right here is 8. If I ask you the f of 3, the answer is going to be 8. You go to the closed circle.
So what's the point of the closed circle being there at all?
Because I'm trying to show you that the graph has what's called a jump. The graph has a sudden change in value.
Okay.
And because of that jump, I have to show, look, the graph was initially heading right here, but then just changed values suddenly. It's like, for example, you know, the bank kind of gives you money every day. So every day the bank is putting interest in your account. So your amount of money is going up. But then on the third day of the week, you put a deposit in there yourself. So if you didn't put the deposit, you would have ended up here. But then you end up putting an extra $1 in your account. And so the amount of money you have will just jump up to 8 if you look at the bank account at the end of the day. Okay? And similarly, over here, if this right here is 5 and this open circle is at say 3, and then this closed circle up here is at 7.5, if I ask you to find f of 5, the answer is going to be 7.5. Okay, because you go to the closed circle. If there are 2 open circles, then the answer is no solution.
Repeat that. If there's 2 open circles, then what?
The answer is no solution. So if I can make this a little bit longer, my graph, if I make my graph go a little bit longer, and then I get to this point right here and I have an open circle, and I have another open circle and it continues. So let's say that number right here is 10. F of 10 will be no solution. Because there's an open circle at each end. Open circle means there is no answer. Since there is no answer anywhere, the graph has no solution at that point. Okay?
Yes.
Anybody else? Questions? Comments? Queries? Concerns? Okay, cool. People, y'all need to turn your camera, man. I need to see what you're doing. Because for all I know is y'all half asleep. I done bored you all to death and y'all all gone to sleep. Let me see those smiling faces. All right. Oh, wow, somebody got light in the background? You got lightning in the background? Mr. Oliver? Several colors at the same time. All right. So that brings us to the major problem. Dum, dum, dum.